Alright, this is going to be episode number 14 in our video series of Go From Noob to Veteran ASM Coder. So here in episode 14 we're going to talk about a thing called the pointer trick. But what I want to talk about first is in episode 12 I explained in detail about using the exception vector area where your ASM skills might get to a point to where if you want a certain cheat to work in the game the way you want it, you might have to use two ASM codes instead of one. Essentially, you'll have one ASM code that will when the address gets executed, a certain register will have a value that you need for your other ASM code, your other address per se. So the first ASM code will store that register value to the exception vector area, which is unused static memory, and then the second ASM code will load that value and just execute however you want depending on the amount of the value that you stored and loaded with. Okay, so with all that being said, let's say you want to create a code that utilizes the exception vector area. It's two ASMs, and remember how I talked about in the beginner level threads when the video series was covering that point in time that you might have a breakpoint that could fail? Well, let's say you set a breakpoint in dynamic memory and for whatever reason it fails. We have a little workaround that you could possibly use. It's called the pointer trick. So here, I'll give you a moment to look at that. So we're just going to use some made up default instructions and some made up values. And this is pretend that we're searching for a value and it only happens during, like, let's say the countdown of the race, right? Okay, and we want to know the static memory address instruction that reads that value, and let's say we know chances are it's going to only execute during the countdown of the race and it's only going to break or execute once. So we set the read breakpoint on this byte because let's say this is the value that we want. We set a read breakpoint on this 52 byte, and for whatever reason it doesn't break, no matter what. And you tried everything. You tried during the countdown, during the race. You even tried a write breakpoint instead of a read breakpoint. Doesn't work. What do? Well, first, what you want to do is you want to look around in dynamic memory wherever you're at, and let's say we're here and we see this half word value, but it's unrelated to what we're working with. But let's just say, okay, I'm going to set a read breakpoint on it, and maybe we can break this value nearby and work with this, right? So let's say you set a read breakpoint on this half word value. So you would set a read breakpoint at 81104012, okay? And it actually breaks during the countdown. It only breaks once, right? So perfect. So now what you need to do is, let's say it breaks at the half word value and it comes up with this default instruction, just for sake of argument, okay? So it's loading this half word value that's right next to the byte value that we actually want, and you should know from previous episodes what this instruction does. It adds this source register and this offset value for the effective address, right? And that effective address directly points to this half word value that we break. So that means that R31 equals 8114, let me make sure this is correct, 8110 4002. Because if you take R31's value and add 10, it would equal that, right? 4012, and the 4012 points right to the half word value. Give you some time to digest that information. Okay, so with all that being said, here's what we do. Instead of storing a value to the exception vector, we're going to store a memory address, or what we call a pointer. So by putting the default instruction at the bottom, we can safely use R5 if you've been paying attention on the video covering register safety protocol. And we're going to store, what we're actually going to store is R31. And I'm just picking a random place in the exception vector area. It's whatever you choose. We've gone over, there's a bunch of ranges you can work with, but for now we're just going to store it to 8000 0F98. We're storing R31 because R31 is the value in R31 is being used as part of the effective address calculation, right? So we're storing this value to 8000 0F98. So that means once this ASM code gets executed, once this first ASM code gets executed, this memory address will have this word value. Okay, makes sense? So instead of an integer value or maybe like a floating point value, we're storing a memory address value. So for your second ASM, let me put some like that. Now for your second ASM, let's say we're following standard safety protocol. So we're just going to use R12 for this one. Now what we're going to do is we're going to load the word, because remember, memory addresses are entire word. This is why we use the store word instruction, because this is a word in length, obviously. Let's just say, for sake of argument, we have no use, we don't need to preserve R12's original value that we initially set, so we can do that trick, that tips and tricks I talked about in the episode of ASM tips and tricks. This is called loading a register into a register. So at this particular point, after this instruction gets executed, R12 will equal that. Okay? So we know that it contains the dynamic memory address that's pointing right here, just 10 away in hex from the half word value that we broke. But keep in mind, this is the goal, this 52 byte, okay? So now you're probably thinking, okay, I'm gonna do this. This is what a newbie code creator might do by mistake. Okay? Now this is incorrect. One, there's a couple mistakes here. Two, you're loading a word value, okay, which we want a byte value, so obviously that's incorrect. And second, this would point to loading the half word value. We're only using the half word value as a breakpoint index per se, right? So there's two mistakes right there. So to get from here to there, from the half word to where a byte is, we increase 1, 2, 3. So put this 1, 2, 3, 10 plus 3, 13. Changes to a byte, because remember, we want the byte value. And thus, once this gets executed, equals our byte value. And then the rest of your ASM, whatever you need it to be, you got it. Because now R12 is the byte value that you need. So this is a perfect example of the pointer trick. What you need to do if a certain value doesn't break, what you need to do is just look around whatever portion of dynamic memory you're in, set a breakpoint on that. Hopefully it breaks at the time that you want it to break. Store the pointer, and then set in the second ASM, load the pointer, increase the offset accordingly when you load from the pointer. Okay, so that's pretty much it, guys. That is the pointer trick. Can be very handy if you have some trouble setting some breakpoints. So in the next episode, I'll cover how to convert annoying floating points to normal integer values. Alright guys, thanks for watching.